Hello, everyone, and welcome to Crazy Data Science, the YouTube channel that uses real world data science methods and techniques and applies them to problems you never really thought you had. Before we get started on this video, I'm really excited about one thing. Have you seen the beautiful new Crazy Data Science logo? I absolutely think it's awesome. It's just like a crazy little robot with graphs popping out of its head. It perfectly symbolizes exactly what we do here on this channel. So now that we got the logo out of the way, back to the video. I think the problem we are going to solve in this video is quite familiar for a lot of people. Imagine yourself being at a birthday party. Perhaps of friends or family or whatever. You're having a good time, had a couple of laughs, enjoyed a couple of beers, and then there is always this one guy that always has to start off the discussion by asking, guys, what do you think is the most metal song ever created? And then all of a sudden the discussion explodes. There are people screaming from the left, Metallica, people from the right, Slayer, and people from everywhere just screaming all types of songs and bands through each other, which ends up in a complete mayhem, fist fight, and all of that kind of stuff.
That's bullshit!
We aren't called Crazy Data Science for nothing, so I decided we're going to end this discussion for once and for all using data science and by building a model that basically labels how metal a song is. If that doesn't get you excited, honestly, nothing will.
So, how did we go about and tackle this problem? As you can imagine, teaching a computer to listen to music and then classifying how metal a song is pretty difficult. So we went a little bit of a different direction. What we're going to do is we are going to get a lot of MP3s and we are going to label those MP3s what kind of genre they are. And we are most interested in everything being either metal or being non-metal, which is basically just the way it's supposed to be.
Oh, that's brutal.
What we're going to do with the MP3s is we are going to convert them in a format called a spectrogram. And as you can see behind me, this is a visual representation of the music. It's basically the energy that's inside songs, and it's kind of like a condensed graph. We are then going to cut the spectrogram into little pieces and label each piece. Is this non-metal or is this metal? Then we're going to place all those slices of music into a convolutional neural network, which we're going to build using TensorFlow in Python. We're going to train that network to basically detect, based on the spectrogram of a song, is this part of a song metal or not. Then we're going to grab the results of all the single parts, combine them together, and voila, we know exactly how metal a song actually is. So let's get ready and start coding and see how this works. So you're all looking at my screen right now, where I created a folder called a metallometer, because that's how I labeled this experiment. And we got a couple of folders and files here. The first one I want to show you is a script I wrote in PowerShell, which is responsible for generating the spectrograms. So I'm gonna edit this, and I'm gonna show you how it works and what it looks like. Zoom in a bit. First of all, I need to set a couple of locations. I'm using a program called SOX, which is able to convert MP3 songs into the spectrograms we need. I'm setting some paths and I'm doing some tricks to detect all the files that have an MP3 extension. So I'm placing all the MP3s that I want to generate spectrograms from into a folder. And in PowerShell, it's the raw MP3 path, which is the folder called raw. It doesn't have any files right now because I've already converted them to spectrograms, but we are going to convert one at a bit of a later state. What it will do, it will grab all the MP3 files inside that folder, and get some information from the MP3 file. As you might know, inside MP3s you can give tags to songs, like what genre is it, which album was the song on, things like that. We're basically going through every item in the folder right now and extracting the name of the song and the genre. And then the next thing what we need to do is we are going to create a mono MP3 file. Stereo, as you know, is 2 channels, so which would have ended up in us having to generate 2 different spectrograms. So what we're kind of doing is flattening the MP3 song into a 1 channel mono audio and then generating the spectrogram. So after we've created a mono file, we're gonna call SOX, which is the program you need to install to generate spectrograms, and basically tell it for each MP3 file we just converted to mono, generate a spectrogram and place it inside the path we defined at the top of the PowerShell. What this will do is it will go through all the mono MP3s, call to the SOX application with these variables, generate a spectrogram of the song, and write it into the spectrogram folder. So I'm going to show you an example of this. As you see, the song called Ace is High by Iron Maiden magically appeared on my screen. It's an MP3 file, and if we inspect the file, you can see the musical genre is metal, which is exactly what we wanted. What I'm going to do is I'm going to grab the Ace is High MP3, convert it to mono, and then generate a spectrogram. So we're going to run through this code step by step. First set some locations, and then go through every file inside the MP3 folder, the raw folder, create a mono file, which we defined here, and generate the spectrogram. There's only one file, so this should be very quick.
Many hours later.
And it's done. In this case, it generated an error because there is some kind of tag inside the song that it cannot process, but we can ignore that. So if we go back a folder and go to the spectrograms folder, we have a file here called aceshigh.png. And if we open it, you see a huge file. Let's zoom in a bit to see what it looks like. As you can see, this is a spectrogram of Ace is High. This is the visual representation of that famous Iron Maiden song. So this is already very useful. You can basically see musical energy and identify instruments that were used and intensity that was there when recording this song. So this is a very interesting piece of visual representation of an audio file. I'm gonna close it because I cannot give like such a huge file to a convolutional neural network. We generally want to cut them up into small chunks, preferably all the same file size, and then feed them into the convolutional neural network. So this is where the next step comes in. In this case, I'm running a Python script called slice spectrograms, and the only thing what it does, it will open the spectrogram and cut it into identical pieces of 128 by 128 pieces, and it will save them into a slices folder. So I'm going to run this Python command to generate the slices from the huge spectrogram and divide them into equal 128 by 128 parts. This should be fairly quick. It generated 105 slices of the Ace is High song. If we go to slices, you can see there are some additional folders which we will use later on, but you can see all the different slices it generated from the spectrogram that we had. So for instance, this is a part of the Ace is High song. This as well. So it cut it up into pieces. What is cool to mention with this is that each slide represents around 2.5 seconds on average. So we're looking at 2.5 seconds of Ace is High here. So when all of our slices are generated and we labeled it, we can start to train our convolutional neural network. The way I did that is inside the slices folder, I have a test and a train folder. And in the train folder, I have created two subfolders. One that's called non-metal and one that's called metal. What I just did to the Aces High song, I did to a lot of songs. And basically slice them up and place them into this folder. So these are various songs. In this case, I gave the genre as the name. So we got some rap slices here. We got some pop songs, some classical songs. I've all converted them into spectrograms and cut them up into slices. I did the exact same thing for metal songs. So I just looked at all different kinds of metal songs by different bands like Iron Maiden, Metallica, Slayer, generated the spectrograms and cut them up into pieces and giving them and placing them in the training folder in the metal folder. All right. When we're at this stage, basically all of our preparations is ready. We got our data, we got the slices, we labeled them. So when we're going to train our convolutional neural network, it will know whether something is actually metal or something is not metal. And it will identify that for each slice. So what's the next step is that we need to train our convolutional neural network. And like I said in the introduction, we are going to use Python for that. So I'm going to quickly start up my Jupyter Notebook and go to my Python project, and I'll show you how to train the neural network. So as you can see, I'm importing a number of libraries here, which we need to build and to analyze, evaluate our neural network. The most important one here is tflearn and TensorFlow, because those are required in our case to build a neural network. And I'm also setting the directory here where we're going to grab the spectrogram slices from later. Let's play this. Let's go to this one. So this is basically the layout of our neural network and how it's going to process our images. So the first step is our input shape, which is our spectrogram images. They are 128 by 128. Remember, we've cut them up into those equal parts. After that, there are a number of so-called convolutional layers. And a convolutional layer in a convolutional neural network basically is a little box that moves across the image it's been fed into and learns certain things from that image. Apparently I did something wrong with my folder in the meantime. So I forgot a slash. I'm terrible at Python. I always forget slashes in Python. Let's fix it. At the end of the convolutional layers, all those layers are going to be connected again, and we're going to have an output. And that output is basically going to be for each slice we feed into it. Is it a metal slice or is it a non-metal slice? So we're going to define the model and create it. So what this step does, this one basically grabs all the spectrogram slices we created earlier, which are inside our training folder, and it's going to load them inside the data frame. And based on the folder they are in, it will know, is this slice a metal song or is this slice a part of a non-metal song? So it will know the labels as well, which we need for training. So I'm going to run this code. And as you can see, it's been adding the non-metal, and it's added the category metal into our data frame. In total, we have 2,833 spectrograms, of which we have a training data set of 1,984. What we also do while loading in this data is we create a validation data set. So while we are training our model, we can immediately validate how good are the steps we are taking to optimize our neural network. In the next step, we are going to train the model. And I'm going to step out a bit and I'm going to skip this, and I'm actually going to load a pre-trained model that I trained earlier, because training it can take quite some time. I've been training it on my own machine, which has a GPU, which means it's optimized for GPU processing, and it's a lot faster than CPU processing, but it can still take quite some time. So that's why I've added a little thingy here to load an already pre-trained model, which I'm gonna do now. There you go. So I'm gonna skip the training, but what I can do right now is I can look how the training went for the model I created earlier. So let's see how my model training went. As you can see, we started up with a very low accuracy. That basically means how many times was the training right using the validation set to basically learn how good can I identify one of those spectrogram slices, whether it's metal or non-metal. But the good news is when the training took longer and longer, our accuracy got higher and higher, which is actually what you would want to see. So far it looks like this model is doing really well. So now we have to get started with the real test. We're going to throw some music or some MP3s against it and ask it to predict every slice if it's metal or non-metal. So I'm opening a function again, which is the same one we've seen earlier that grabs the training data, but in this case I'm gonna grab the spectrogram slices from the test folder. Now, I've already prepared some spectrogram slices of a song, which happens to be the song Shakira with Hips Don't Lie. I'm on tonight, you know my hips don't lie, and I'm starting to feel it's right. That's definitely not metal. But let's see what our model thinks. So what I'm doing, I'm going back to my Jupyter notebook. I'm gonna load in all those slices of Shakira Hips Don't Lie. So let's do that. There you go, all the slices are inside the data frame right now, and we are going to predict. So I'm using the predict keyword, I'm telling it to use my model that we trained earlier, and I'm telling it all the slices that are inside this data frame that I'm feeding to you, do a prediction. So let's see how that works. Done. So that was really quick, that was like 1.5 seconds. The prediction is done, but it's inside a variable. And in our cases, we are going to convert the results a bit so it's a bit more readable for us. And as you can see in this case, I'll have to explain this a little bit, but you see all those zeros. Each zero represents a single spectrogram slice of Shakira's Hips Don't Lie. They are all zeros. So all zeros means non-metal. If there's a 1, it means this slice was classified as metal. So apparently Shakira's Hips Don't Lie isn't a very metal song, which is kind of like we expected. Let's see how good we scored actually. Yeah, we have 85 slices classified as not metal and 0 slices classified as metal. So yeah, we can kind of conclude that Shakira Hips Don't Lie is not a metal song. So if you're ever in a discussion with someone about that, you can be pretty sure you're right. Let's move over to something more metal though. In this case, I've changed the contents of my test folder. I removed all the Shakira slices and placed the spectrograms of a song called Angel of Death by a band called Slayer. You might remember those guys from one of our previous videos. So let's see how metal Angel of Death actually is. And a funny fact is, if you're a Slayer fan, Angel of Death has always been ranked as one of the most metal songs of all time. So let's see how our model is doing with detecting that. In this case, I'm going to read in all the slices again, because we do not want to have the Shakira slices there. Here you go, all the Angel of Death slices. And we're going to predict each and every slice. It's rather quick. And let's again look at these numbers. Remember, if it's a 0, it's not metal. If it's a 1, the slice has been classified as metal. There is definitely a lot more 1s here. Let's see. We actually have 109 slices that have been labeled metal and 4 that has been labeled not metal. I would be very interested in knowing which parts of that was, but for this experiment, it doesn't really matter. The slice just wasn't classified as metal because I like to show things in a more nicer way. This little bit of code is basically the metalometer that kind of calculates in a percentage how metal is this song. So let's see how Angel of Death does. Angel of Death scored 96 on a scale of 100 on a metalometer. So this is probably one of the beep metalist metal songs ever. So this is totally cool. This is completely correct. It classified this song as metal, and it absolutely is metal. And it scored really well as well, which kind of proves the point that Angel of Death is actually one of the roughest metal songs ever created. Let's look at some graphs, because we like graphs to see how we performed. So this is the graph of the percentage, how much scored metal it was. So again, just a visual representation of the metalometer you saw earlier. Can we see which parts of the song were the most metal? Like I said in the introduction, each slice is like 2.5 seconds. So what I'm doing with this graph is basically I'm plotting all the slices and I'm showing you which one is labeled metal and which one isn't labeled metal. So you can practically go to the timeline of a song, listen to it, and just know which part were identified as metal or not metal. So let's see. So in this case, the start time between 0 and 2.5 seconds was 92%. We were sure it was metal. So there's a very small chance it wasn't metal. And this is how we do this for every slice. And as you can see, most parts are pretty sure that the slice is metal. But in, for instance, this case, let's see, it's a bit less sure. It's only like the start time from 10 seconds on, so from 10 till around 12 seconds. It's 62% sure the slice is metal and 37-ish% it's not metal. Let's throw this inside a graph. And here you go. You can see like how sure for each slice and a time in seconds how metal is this slice. And as you can see, in most cases we are very high. The thick blue line is the score on the metal, is very high. Somewhere in this area between 100 and let's say 150 seconds, the algorithm isn't really sure. So maybe this is the bridge of the song that has a bit more relaxed portions where the model doesn't necessarily or isn't very sure it's actually metal, or maybe it's something from a non-metal song which we trained to model on. So to summarize things up, what we did in this video is we helped build a solution to solve the ancient mystery about which song is the most metalist song. The way we did that is by getting an MP3, converting it to a mono channel, and generated a kind of like a musical graph called a spectrogram. We cut the spectrogram up into pieces of 128 by 128 pixels and labeled each slice whether it belonged to a song that's metal or a song that's not metal. We fed all those slices into a convolutional neural network using Python and TensorFlow, and we let the network train on all those images, get better, learn to identify which slice could be metal and which slice could be not metal. We ended up by giving up a very metal song called Angel of Death to the model, and we let it predict, or basically we let it analyze all of the slices that made up Angel of Death. And what we found out is that Angel of Death by Slayer is actually a very, very metal song. We also tried it on Shakira with Hips Don't Lie, and as expected, that wasn't very metal. So, to end up everything, there are links in the bottom to our GitHub page and our YouTube page. If you like this video, please put up the little thumbs up and give us a like. And if you want to stay up to date with all the new crazy data science videos we are going to do in the future, please subscribe to this channel. Thanks for watching.